class. Binomial theorem. It's an important chapter, and regularly previous year questions have been asked from this chapter, and this is also an important yet simple chapter. Okay, so let's start with the definition with the first word that we have learned here and read here: binomial theorem. Binomial. So by binomial we mean wait a second. So, binomial theorem. Nomial here means term, and as bi means two. So we're discussing about the theorem which is related to somewhat two terms having some power raised to the power. Let's say its first term is x, another term is y. There's some power. We'll be expanding this expression. We'll be expanding this expansion using the binomial theorem. So traditionally, if I write x plus y raised to power 0, and it's obvious this anything raised to power 0 becomes 1. If I write x plus y raised to power 1, so it's itself only write x plus y whole square. We have learned its value earlier like this. X plus y whole cube. We also are aware about the value of this term. But how about if I write x plus y raised to power 4? That is something that we are unaware about, right? So we'll have to use binomial theorem for that particular case. So binomial theorem, and also one more pattern that we have observed by us as the pattern's name is Pascal's triangle. So Pascal's triangle basically gives us the coefficient of terms, and we have got to know. So we'll discuss Pascal's triangle a little later after we have discussed binomial theorem. So binomial theorem. So first, let me just simply write what is a binomial theorem for positive index first. Okay. So x plus y, these are two terms raised to power n. The first term starts with its full power, x raised to power n and y raised to power 0, multiply with the combination of n, c, 0. Then the second term, x loses one power, y raises and gains one power, and c of 1. X loses another power, y gains another power, selection of 2 out of n. So this is how this will go on. And the second last term will be nc of n minus 1, x raised to power n minus n minus 1. So basically n minus 1, that is 1, y raised to power n minus 1. So nth is the second last term. Last term is ncn, x raised to power 0, y raised to power n. If we discuss about the rth term, which means rth term will look like nc of r. No, actually, it's not the rth term. You are talking about the r plus 1th term. Okay. So NCR x raised to power n minus of r into y raised to power r. This is not the rth term. This is the r plus first term. As we have seen, value here is 0 for the first term. This is the first term, right? The first term. So by observation, of terms from here, we can get to know that NC of R, then this should be the R plus 1th term. Okay. So before moving ahead, let's discuss the basics that we are going to use in this chapter. Basically, n factorial into n minus 1 into n minus 2. This will go on till it becomes n minus n. Till it becomes n minus n factorial, which is 0 factorial, which is 1. Okay. And I hope you are aware about its value. I hope you are aware about its value. And we can also write this in the format of that this will go on till the natural number becoming 3, then 2, then 1. Okay. Or directly 1 whenever n is 0. Basically, for 0 factorial, it is 1. Chalo. This is about n factorial. There's also something else. We were discussing NCR. NCR is basically the selection of the number of selection of R things out of n. So its formula is n factorial upon n minus R factorial dot factorial. We have also studied this in the chapter of permutation combinations. Here n is natural number. R is also a natural number. And R has certain range. R cannot be negative. In even natural numbers also cannot be negative. That's why also. And this lies between 0 to n and R being a natural. So let's revise some properties of NCR, which will be useful for us in the chapter. NCR plus NCR minus 1. That becomes n plus 1 C of R. Let's also revise one more important formula. Let me write it here. NC of R is equals to NC of n minus R. Basically, the key is its sum should be n, and the n should be equal. First, second important property. Third important property to recall is the ratio of terms. Binomial coefficients here. So n minus r plus r minus minus plus divided by simply n. That's it. These are some important properties. Let's now go back to the theorem. So here we can see the power of x started from the maximum that was there in its power. And if this is the rth term, like the first term is having 0 here, second term is having 1 here. So which term is this? This is n plus first term. So how many total terms are there? 1. Total number of terms in x plus y raised to power n is n plus 1. That's important thing to take care. And also here we have learned about the general term, that is the rth term. The general term. So the rth term will be tr plus 1. Let's find out the r plus 1th term. No. Okay. So nc of r x raised to power n minus r into y raised to power r. We are also aware, be able to find out the rh term by finding out ncr minus 1, but this is like more convenient for you to learn it by learning the tr plus 1th term. Here, one thing to notice, these NC0, NC1, NC2, NCN minus 1 or NCR or NCN. These are called binomial coefficients. Let me write using a different color. These are binomial coefficients. These. One more observation that we can make here, the sum of powers of both of the terms, n plus 0, n minus 1 plus 1, n minus 2 plus 2, there is also n. So one more observation that we can make here is that the sum of all sum of indices, so right, sum of indices of x and y is n in all terms. That's one thing to take note about. And also, as we were discussing about NC R being equal to NC of n minus R, so means the binomial coefficients which are equidistant from the starting and the end will be equal. Like NC0 is equal to NC, and we know because of 0 plus n is n, and NC1 is equals to NCn minus 1. Why? Because 1 plus n minus 1 is n itself. So the binomial coefficients equidistant from the starting in the n are equals. Let me write this in the next page. So these are some observations. The binomial coefficients of the terms equidistant from start and end are equal. That is one observation. Okay, so let's straight away solve a question. The question is that we have to expand x minus 1 by x raised to power 6. Let's do it. So here, first of all, NC0, n is basically 6 here, and the first term is x, the second term is minus 1 raised to power x, which can be written as minus 1 x raised to power minus 1. Okay. So binomial expansion NC0 6 C0 x raised to power 6, and this is power 0 means nothing, plus 6C1 x raised to power 5 into minus of 1 by x raised to power 1, and it will go on and go on. Last terms will become 6C6 x raised to power 0 minus 1 raised to power 6. So it will be very tedious for us uh, to do the calculation again and again. So instead of that, we'll just find out a solution for it by finding out the general term. A simple formula to write all the term. So in general term, we are looking for tr plus 1th term, 6c of r x raised to power 6 minus r into minus of 1 raised to power r. Okay, 6cr remains 6cr. x raised to power 6 minus r. Minus 1 raised to power r and x raised to power minus of r. The base is common here. The powers will get added. So 6 minus r minus of r becomes 6 minus of 2r. Minus 1. So minus 1 raised to power r, 6cr into x raised to power 6 minus 2. This is the general term. Okay. Using this general term, you'll be able to find out all of the expenses. Let's do it for the sake of the example. Okay. So x minus 1 by x raised to power 6. First term means we have to find, now we have r is equals to 0. So 6 is 0, x raised to power 6 only. When r becomes 1, that is an odd number, so the term will become negative. 6c1, x raised to power 6 minus 2, that is 4. Now the r becomes, r was 0 here, r was 0 here, r was 1 here, r becomes 2. Odd power, positive sign, 6c2, x raised to power 6 minus 4, that is 2. Minus r is equals to 3. Odd power of minus 1, we make it a negative term. So 6c3, x raised to power 6 minus 6 becomes 0. R raised to r is equals to 4. And so the sign will be positive. 6, 3, 4, x raised to power 6 minus 8, that is minus of 2 this time. R is equals to 5, odd term, negative sign, 6, 3, 5, x raised to power 6 minus of 10, that becomes minus of 4, plus r is equals to 6, so plus sign, 6, c 6, that's the last term, x raised to power 6 minus of 2 into r, minus 2 into 6, minus 12, minus 12 plus 6, minus of 6. So this is the complete expansion of our term. And also we can further go on and say solve for the value of 6c0, which is actually 1. 6c0 is 1 and 6c1 is 1. So 6c1 is 6. So we can also do that. 6c1 is 6 and 6c2 is, we have to find out actually this. 6 factorial, 4 factorial, factorial, this cancels 6 by 5, 2 cancels 6 by 3, 3 by 15, 3 into 5 becomes 15. Okay, 15 raised to power x square minus 6c3. 6c3, 3 factorial cancels 6 by 6 into 4 into 5, 6 into 5 into 4 actually. 3 factorial cancels 6, this becomes 20 minus 20 plus raised to divided by x square. 64 is actually equal to 62, which was 15. Minus of 65 is 6 divided by x raised to power 4. 66 is 1 only, x 1 x raised to power minus of 6, so can written as 1 by x raised to power 6. So this is the expansion. Okay, let's now take one more example. Very much similar to previous equation that is asked. So we have to find 11th term in the expansion of the expansion of 3x minus 1 by x root 3 raised to power 20. This is what we need to find out. 11th term. So to finding out 11th term, the formula of r plus 1th term is NCR. N is actually 20 here. So 20 C 10 3x raised to power my mistake. No mistake, no mistake. We have to find out 11th term. So r plus 1, r is 10 here only. Okay. 20 minus 10, that becomes 10. Minus 1 raised to power x root 3 raised to power 10. Minus 1 raised to power 10 becomes, minus 1 raised to power 10 becomes plus 1. 20 factorial divided by 10 factorial into 10 factorial. That is the 11th term. 3 raised to power 10 into x raised to power 10. Minus 1 raised to power 10 becomes plus 1. Divided by x raised to power 10. Root 3. That is 3 raised to power half raised to power 10. X raised to power 10 cancels x raised to power 10. Okay. And let's solve this. 10 factorial you cancel 20 by 20 into 19 into 18 into 17 into 16 into 15 into 14 into 13 into 12 into 11. 10 factorial is actually 10 into 9 into 8 into 7 into 6 factorial. We are aware about the value of 6 factorial, that is 720. So we can cancel 20 by 720 straight away by writing 36 here. And 18 to the 36. Okay. And what else we can cancel? 7 to the 14. 8 to the 16. 2 cancels. 9. Okay. 18 is already gone. So there's 9 by 3 becomes 3. 12 by 3 becomes 4. And 3 divides 15 by 5. We have to be careful. And 5 divides 10 by 2. 2 divides 2. There's nothing significant left here in the denominator. 3 raised to power half into 10 becomes 5. So this is actually 3 raised to power 5. 3 raised to power 5. So, okay. Is there any multiple of 3 here? Yes, ये रहा 3 raised to power 10. 3 raised to power 5 cancels 3 raised to power 10 by 3 raised to power 5. Is there anything else left? No, there's nothing left in the denominator, so no use of looking in the denominator. Okay, so the 11th term will become 13 into 4. Okay, let's write everything. 13 into 4 into 11 into 19 into 17 and into 3 raised to power 5. Okay. So this is how we can solve it. This is an example, long example. If this question will be asked in your ND, so you will not be in the options. Their options will include 20C2 and then some value, let's say 3 raised to power 5 into x or something like this. Options will be like this, so you will not be required to solve the value of 20C10 because that is very long to do so, and UPSC will not ask such questions which are calculation driven. They will ask questions which are concept driven. They are keen to test your concepts. We will be solving previous year questions also. In the next question, in the next example, we have to find out the term which is independent of x in 3 by 2x square minus 1 by 3x raised to power 9. So we have to find out the term which is independent of x. So simple, first of all, we will find out the general term. TR plus 1 term. N is 9. CR 3 by 2 into x square raised to power 9 minus r minus 1 by 3x raised to power r. So let's solve the expansion, the general term first. 3 raised to power 3 by 2 raised to power n minus r and x squared. So 2 into 9 minus r becomes 18 minus 2r minus 1 raised to power r and 1 by 3 raised to power r and x raised to power minus of r. X raised to, because 1 by x raised to power r means x raised to power minus of r. Okay, so 18 minus 2r and x raised to power minus r. So the base is same, so the exponents will be added. So 18 minus 2r minus of r becomes 18 minus 3r. Okay, now we know that this is the general term, and the term which we are looking for in that particular term, there should not be any index of x, because like the x will only go away when its power is 0. Okay. Here. Okay. So x power is 18 minus 3r here, which should be 0. 18 is equals to 3r. R comes out as 6. So R has to be 6 to find out the term which is independent of x. So the seventh term will be the independent term of x, NC of 6 3 raised to power 2 n minus 6. Sorry, 9 minus 6. 9 minus 6 is 3. X raised to power 18 minus 18 becomes 0. Minus 1 raised to power 6. That is plus 1 only. 3 divided by into 1 by 3 raised to power 6. Okay. This was 3 only, na? So 3 raised to power 3 divided by 2 raised to power 3. We can expand this by writing 3 raised to power 3 into divided by 2 raised to power 3. 3 raised to power 3 cancels 3 raised to power 6 by 3 raised to power 3. And the seventh term becomes 9c6 plus 1 divided by 2 raised to power 3 into 3 raised to power 3. Now the power is same and the base is different. The bases will get multiplied in this case. 2 3 becomes 6 raised to power 3 and in the numerator comes 9c6. Okay. So let's find out its value also. The term independent of this is 9c6 divided by 3 raised to power, sorry, 6 raised to power 3. Yes, 6 raised to power 3. 9c6, 9 into 8 into 7 into 6 factorial divided by 3 factorial into 6 factorial into 6 raised to power 3. 6 factorial cancels 6 factorial. 3 factorial is 3 into 2. 2 cancels 8 by 4. 3 cancels 9 by 3. Now 3 into 4 into 7 divided by 6 into 6 into 6. 3 cancels 6 by 2. 2 cancels 4 by 2. 2 cancels 6 by 3. That becomes 7 by 18, which is our answer. Okay. So on the similar lines, we have another question, another example to discuss. That is, in this question, we have to find out the coefficient of x raised to 7 in the expansion of ax squared divided by bx raised to power 11. Okay, so this is the binomial expression. First of all, let's find out the general term. 7cr into ax square raised to power 7 minus of r divided by 1 by bx raised to power r. Let us simplify. 7cr a raised to power 7 minus r into x raised to power 14 minus 2r and x raised to power minus r also. So this will get subtracted here only and b raised to power minus of r. That is the general term. We are aware that x we have to find out the coefficient for which the x index is 7. So 14 minus 3r should be 7. Okay, so 14 minus 7 becomes 7. It's close to 3r. Now that is not possible. That is not possible. Hmm. We have done a mistake. Then that's very foolish mistake. The n was 11 here, not 7. We were obsessed with 7 because of this. This is called priming in psychology, that we got primed with this number and we got a wrong input and ended up solving the question incorrectly. Because the n was 11 here originally. Apologies for my mistake. Let's now solve the question once again. So 11 C R ax square raised to power 11 minus r into 1 by bx raised to power r equals to 11 of c of r a raised to power 11 minus of r x raised to power 2 into 11 minus r, that is 22 minus 2r, okay, into 1 by b raised to power minus of r into x raised to power minus of r, which will get further subtracted here only. So the x index has to be 7, and but here it is 22 minus 2r minus r, that is 3r. Let's bring the 3r onto the left hand side. This becomes 22 minus 7, which is 15. R comes out as 5. And we have to find out the coefficient. So the term will be sixth term, which will be having x raised to a 7 and 11c of 5 a raised to power 11 minus 5 becomes 6 into b raised to power minus of 5. That comes out as 11c5 a raised to power 6 divided by b raised to power 5. That is precisely our answer, correct answer. There is one more important question example. Let's discuss the last example. It's important. Question says we have to find the number of rational terms. We have to find out the number of rational terms in the expansion of 9 raised to power 1 by 4 plus 8 raised to power 1 by 6 whole raised to power 1000. We have to find out the number of rational. Now, what is rationality? Any number that we can write it in the form of p by q. But going by the definition, it will be hard for us to define the terms which will be rational, which will be not. So we better refer to irrational terms, which include terms having square roots or cube roots or power in fractions. Here, the power will be in fractions. Then we'll call that particular term as irrational. If the power is in integer, we'll call that particular term as rational. That is the basic concept. Let's find the general term as always. TR plus 1. So 1000 CR 9 1 by 4 raised to 1000 minus R into 8 raised to 1 by 6 4 raised to R. This is the general term. Let's now first solve the powers. So we are aware that 9 is actually the square of 3 and 8 is actually the cube of 2. So we have made the base as prime numbers. 3 raised to 2 into 1 by 4 into 1000 minus of 1. Multiplied with 2 raised to 3 into 1 by 6 into R. Now the general terms becomes 1000 CR. This cancels. Then 3 raised to R becomes 1000 minus R divided by 2 into prime number 2. 3 cancels 6 by 2 and it becomes R. So this is the general term of this binomial expression in terms of prime numbers raised to some powers. So these powers, if these powers become natural number, if this is a natural number, this is a natural number, these particular terms will be called as rational numbers or rational terms. If the powers indices being natural. Otherwise, they will be irrational terms. When indices do not have any natural index. So we are able to observe that this index is actually 500 minus R by 2 and this is itself R by 2. So R is a natural number that we are aware from the definition. But in the natural number, R has to be even number so that, or should I say R has to be the multiple of 2 so that the whole power of 3 and 2 becomes a natural number. Otherwise, R being a odd number will give us only no natural index of 3 and 2, which will end up making our term as irrational term that we will not be able to, that will not be a favorable case for us. So the favorable case, R has to have a even value from the set of natural. Okay. So how many even values can R have here? So we know R's range is from 0 to n, and they are natural numbers like 1, 2, 3, 4, 5, 6 till n. Here n is 1000. So r's value can be not yes 0. It can be even 0, 0, 1, 2, 3, 4, 5, 6 till 1000. But favorable case when r being even, being a multiple of 2, we'll have cases from 0 to 4 like this till 1000. Okay, this is the first term, this is the second term, this is the first term, this is the second, this is the third. So this should be the 500 first term. So total 501 terms are there. There are total 500 rational terms. So this is the possible set of values for R. Okay. So these are the number of rational terms. 501. This was a really good question. Let's move ahead with the next important topic, which is about finding out the middle term. The middle term or terms sometimes of the expansion of the binomial expansion. So we know that for any expansion x plus y raised to power n, there are n plus 1 terms. So we will discuss if n is a natural number. So n can be an odd natural number or even natural number. We are discussing about n. If n is odd natural number, then the total number of terms will be n plus 1, which is even. If n is even, then the total number of terms would be n plus 1, which is odd here. Okay? So, so the middle term in the
Sir,
expansion
can
x
you
plus
hear me
y.
now, sir?
Could you repeat?
Sir, can you hear me now, sir?
Yes, I can hear you, Guru.
Sir, I was not able to on my mic and chat properly, sir, from the beginning of the class.
Okay, not a problem. Shall we continue?
Yes, sir.
Yes. So if n is odd, then total number of terms will be even. So then in that case, you'll be having two middle terms. Like let's take an layman example. If I write 1, 2, 3, 4, these are all four number of terms are there, na? Which is an even number. So here there will be two middle terms. If I write only 1, 2, 3, 4 and 5, these are odd numbers, odd number of terms. So there will be a single middle term. Similarly, here in the case of n becoming odd, our total number of terms will be even. So in this case, there will be two middle terms. One middle term will be t n plus 1 divided by 2, and other middle term will be t n plus 3 divided by 2. When n is even, write properly. When n is even, then there will be only one middle term. That will be n by 2 plus 1th term. This will be the only middle term. It's important. Now there is one thing to note here. This is really important. This point is that the greatest binomial coefficient in the expansion is always the binomial coefficient of middle term. I should say middle term or middle terms. So let's now straight away take an example. We have to find out the middle term. In expression, in expansion. In expansion of 1 minus 2x plus x square raised to power n. Let's solve the question. First of all, we are only aware about binomial theorem having two terms. Here, there are three terms. Let's observe a pattern. 1 minus 2x plus x square. This seems known. This seems acquainted. It is actually the expansion of x minus 1 raised to power whole square. 1 minus 2x plus x square. Okay. So here x minus 1 whole square raised to power n. So we may write the binomial expansion is x minus 1 raised to power 2n. Now we are aware now the n here is 2n. So there will be total 2n plus 1 terms. Odd number of terms. So if there are odd number of terms, then there will be only one middle term. That will be t raised to power 2n by 2 plus first term. That will be t n plus first term, which is actually n is what? N is n here. So n c of, sorry, n is 2n here, my bad. And r is, and now we have to find out n plus 1 term. So we'll take r as n into the first term raised to power 2n minus n into minus 1 raised to power n. So this is the middle term. This will all depend on the value n. This is our answer. Is that clear? Let's move ahead to the next question. Based on this concept only, find the middle term you have to find the middle term in the expansion of 3x minus x raised actually x raised to power 3 divided by x raised to power 9. So this is the question. Now we have to find out the middle term. So n is 9 here. Total number of terms will be 10, actually even. So there will be two middle terms, that is tn plus 1, that is 10 by 2, and tn plus 3, and 9 minus 3, 12 by 2. So two middle terms will be t fifth and sixth term. Fifth term will be NCR. R is careful, be careful that if we are finding out if we are finding out pth term, then R will be p minus 1. Okay, into 3x raised to power n minus 9 minus 4, that is 5, minus x cubed divided by 6 raised to power 4. This is the fifth term. Let's find out. 9c4 3 raised to power 5 into x raised to power 5 minus of, now minus will become positive because of the even power, x raised to power 12 divided by 6 raised to power 4. 6 raised to power 4 can be written as 3 raised to power 4 into 2 raised to power 4. 3 raised to power 4 cancels 3 raised to power 5 by 3, and this becomes 9c4 into 3 into x raised to power 12 plus 5 becomes 17 divided by 2 raised to power 4, that is 16, which is our one middle term. There is another middle term t6 and c5 3x raised to power 9 minus 5, which is 4, minus x cubed divided by 6 raised to power 5. Now this time the minus sign will come out outside because of the odd power. 9c5 3 raised to power 4 into x raised to power 4, x raised to power 3 into 5 15 divided by 6 raised to power 5 can be written as 3 raised to power 5 into 2 raised to power 5. He cancels by 3. This becomes 9c5. Negative sign, of course, x raised to power 5 plus 15, 19. Divided by 3 into 2 raised to power 5. 2 raised to power 5 is actually 32. 32 into 6. 32 into 3 becomes 6 and 9. That is the answer. These are the middle terms of this expansion. Okay, let's now move ahead to the next question. We have to find the term independent of x in the expansion 3 by 2x square root plus square root x by 3, and its whole power is 10. Is that what we need to find out? Let's start. Uh, Term, whenever we are discussing about term, we'll find out its general term. So 10 CR square root of 3 divided by 2x square to square root of x by 3. So square root of x by 3 means x by x raised by half, 3 raised by half, and its whole power is. Okay, now simplifying, this becomes 10c of r. 3 raised by half into 10 minus half, that becomes 10 minus r divided by 2, divided by 2 raised by 10 minus r divided by 2, of course, square also. And x square's square root becomes x raised power minus of 10 minus r, that becomes r minus of 10, x raised power r by 2 divided by 3 raised power r by 2. Cool. So this can be written as 3 raised power r minus 2. Okay. This can be written as 3 raised power r minus 2. And this will get cancelled here. Subtracted here. R by 2. So this comes out as 3 raised power 10 minus 2r divided by 2 into x raised power r minus 10 minus r divided by 2 divided by 2 raised power 10 minus r divided by 2. The term independent of x means x index should become 0. So r minus 10 minus r by 2 should be 0. Let's find out the value of r from here. This becomes 3, r minus r by 2 becomes r by 2 is equals to 10. This makes r, this gives us r is equals to 20. Can r be 20? See and find out. Can r become 20 in any case? No, it can never become 20. It can never become 20. So if r can never become 20, why not 20? Because the n is 10 here. R's limit is from 0 to n is 10 here. So r cannot exceed the value of 10. So hence, there is no such term which is independent of x in this expansion. So the answer of this question will be, there exists no term in expansion which is independent of x. This is the question. The coefficient of two terms are given as equal in this expansion. We have to find out the value of the variable mentioned in the question. That is R. So first, talking about the binomial coefficient, first let's find out its 2R plus fourth term, and let's find out its R minus 2th term. So finding out 2R, so 18 C R is what? 2R plus 4 minus 1, 2R plus 3 into X raised power 2R plus 3. Simple. 18C R minus 2 minus 1 R minus 3 X raised power R minus. Now its binomial, its coefficient are equal. So X will be ignored, and 18C to R plus 3 is given as equal to 18C R minus 3. N is same, this and this. Its sum has to be equal to 18, then only these binomials or like these combinations can be equal. So 2R plus 3 plus R minus 3 should be equal to 18 minus 3 plus 3. It becomes 3R is equals to 18. R becomes 6. So the question that was looking very typical is come out to be very easy, peasy, and cheesy, and also lemon squeezy. That's a very easy question. You just have to solve it mindfully. Now we are aware here in the binomial expansion. The terms, like the largest term is the middle term. And the terms are increasing first and then decreasing later on. So it is for sure that the terms are in some particular sequence. So to find out the greatest term in the binomial expansion, to find out the greatest term in binomial expansion, what that term will look like. It will it will be the greatest term, and it will be surrounded by its all of the terms will be lesser than that, and its surrounding will also be lesser than that. That will be the specific unique feature of uh, the presence of any greatest term in the expansion. Let me write here. Let us say TR plus 1, TR, and TR plus 2. These are three terms in any binomial expansion. So if TR plus 1 were a greatest term, then what will happen? Then this will be greater than TR, and this will also be greater than TR plus 2. Or maybe let's say equal. So the point here is TR plus 1 divided by TR. Its modulus should be greater than 1. Or if I write it on the, should be greater than 1. And also, if we take the ratio of TR plus 2th term, sorry, I should write TR plus 1th term divided by TR plus 2th term. This should also be greater than 1 because TR plus 1 is the greatest term. If TR plus 1 were the greatest term in any binomial expansion. So that's the condition that you have to remember. Now let's discuss about the binomial coefficients a little more. So 1 plus x raised to power n. One plus x raised to power n is basically nc0 x raised to power 0 plus nc1 x raised to power 1, nc2 x raised to power 2, n will go on till ncn x raised to power n. Okay. If we have to find out the sum of all the coefficient, all the binomial coefficients, then we can simply put x is equals to 0. If we were to find out the sum of all binomial coefficients in the expansion 1 plus x raised to power n, then it's simply put x is equals to 0. This will become nc0 plus nc1, because 1 raised to power anything is 1 only, na? Okay. On the left hand side, x will also be 1 plus 1 raised to power 2 raised to power n. That's very important. If we were to find out 1 minus of x raised to power n, then 1 minus 1 becomes 0. And this proves, because x minus 1 raised to power 1 will become negative. So the terms having odd index of x will be negative and others will be positive. This is how this particular expansion is proved. And let me state this very clearly, that these expansions are direct results which are asked in previous year questions of NDA. And I have also given you the explanation that how they have been calculated. Okay, let's consider this as equation 1. Let's consider this as equation 2. And let's do it here only. Let's play with them. Okay, on adding, give me a moment. On adding the equation 1 and 2, what we will get is twice of into it. Two raised power n is equals to twice of all the odd terms, all the even terms, sorry. And this will become 2 raised power n minus 1. That is nc0 plus nc2 plus nc4, like this. Or even on subtracting 1 from second, what we will get is 2 raised power n on the left hand side, and on the right hand side we will get twice of this and this, nc1 odd terms, nc3, and bringing 2 on the left hand side, 2 raised by n minus 2 becomes 2n minus 1, nc1, nc3, nc5 plus dot dot dot. So this is very important. as well. Let me just write all the important results on one slide. And I'm not going to write n again and again. Okay. So you just consider that there is n, C0, C1, and it is the same in all the books. 2 raised per n. When it comes to only odd terms, then it is 2 raised per n minus 1. And it is for the same for odd terms. These are even terms, these are odd terms. Some more important results. NC0 whole square, NC1 whole square, NC2 whole square, dot, NCN whole square. This is equal to 2NCN, which can be further expanded and written as 2n factorial divided by n factorial whole square. Or should I say n factorial 1? It's better to remember 2NCN. One more important formula, NC0 into NCR plus NC1 into NCR minus R plus 1 plus NC2 into NCR plus 2. Okay, this will go on till NCN minus R into NC of N. This will be known equal as 2n full factorial divided by n plus R factorial into n minus of R. What is important? This, and that. And fourth one is also important. Take to remember the fourth one. The sum. No, sorry, the difference. Difference is of R. Difference is of R. Here, NC, the whole square from NC0 to NCN. Here, only the even or the odd terms, binomial coefficient sum. And here the binomial, here is the binomial coefficient sum of all the terms. One thing to remember is 2n factorial can be broken down and written as 2 raised to power n into n factorial into sum of all odd numbers till 2n minus. Let's now take an example. Working. Prove that, or just instead of going find the sum of coefficients in expansion of 1 plus x minus 3x whole square raised to power 2163. But we don't have to worry. What we all have to do is to put x is equals to 1. 1 plus 1 minus 3 into 1 square, basically 3 only, is to 2163. 2 minus 3 becomes minus of 1 raised to 2163. Minus 1 raised to power any odd power, which will give us only minus 1. That is our answer. Continuing the topic further, next important topic is binomial theorem for any index. X plus y raised to power n. So here we were talking about n being natural number. This time we'll not discuss about x plus y, but about 1 plus x. If x is a number lesser than 1, modulus of x is less than 1, or we can say x is less than 1 and more than minus 1, then one special expansion is used. 1 plus x is for n plus 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial x raised to power cube, and this will go on and on till infinity. In the expansion, n belongs to real number. N belongs to real number, I repeat. And n should be positive. N is a real number. Let me write the condition here. N belongs to real number and n has to be positive, greater than 0. And here NCR will not be useful because n is not natural number here. N is not natural number here. It belongs to real number. So we will not be using NCR. If we write it, if x is so small, then its square and higher powers may be neglected. then approximate value of 1 plus x raised power n is 1 plus nx, because the other terms, these terms, are ignored because the x square and the higher powers are neglected. So we will consider this 1 plus nx only. This is how the binomial theorem that we talk about in class 11 in physics comes out. This is the concept behind it. So first, let's now discuss some important results. Then we are going to apply this in questions also. And the results that I'm going to write now are really very important for from the perspective of previous year questions. So first of all, let's take the n as -1, the starting. 1 plus x raised power -1. Well, minus x plus x square minus x cube plus x4 minus x5, and we'll go on like this. 1 minus of x raised power -1, this will become 1 plus of x plus x square plus x cube plus x4 6 raised to 5 plus dot dot. Let's now discuss about the value having plus minus 2 in its power. So here it will start from 1 minus 2x plus 3x square. Let me just wait, give me a moment. Okay. Where will be 1 plus x raised to power -2 is equals to 1 minus of 2x plus 3x square minus 4x cube plus 5x4 minus 6x5. It will go on like this. 1 minus of x raised to power minus of 2, it will make it all the signs as positive. One minus x raised to power minus of 2. Similarly, for cube, we can find out the value of 1 plus x raised to power minus of 3 by 1 minus 3c1 x plus 4c2 x squared minus 5c2 x cubed plus 6c4. Oh, pardon me. 3c1, 4c2, 5c3, 6c4, x raised to power 4. Like this will be moving on. Discussing about minus 1 minus x raised to power minus 3. So it will be 1 plus 3c1 x plus 4c2 square plus 5c3 x cube plus 6c4 x4 will be going on like this. These are really very important. Even the first four are very important, at most important. Let's discuss an example. read this. 1 plus x raised to power n is equals to 1 plus nx plus n into n minus 1 divided by 2 factorial into x square plus n into n minus 1 into n minus 2 divided by 3 factorial. That is 3 factorial, not 31. 3 factorial. Dot 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 till infinity. Example says if x is so small that its square and higher powers can be neglected, then find the approximate value of 1 minus 3x raised to power half plus 1 minus raised to power 5 by 3 divided by 4 plus x raised to power half. We just talked about a property which was 1 plus x raised to power n is 1 plus nx plus n into n minus 1 divided by 2 factorial plus x square, and we'll go on till infinity. We can ignore the value x square, so we'll have to consider this much value in the expansion. So 1 minus 3x raised to power half will become 1 minus 3x divided by 2. Why? We have simply multiplied half with x, whichever x is there. N is half, x is minus of 3x. Okay. For the next expansion, 1 plus n of x. N is 5 by 3 into x is minus of x. This is not something variable. This is just a sign of multiplication. Divided by 4 plus x raised to power half. Now here we need to consider one thing, that we'll have to make 1 here. So we'll take 4 common with its power half. Then it becomes 1 plus x divided by 4 into raised to power half. 4 raised to power half means 4 square root, that is basically 2. So 1 plus 2 of here 2 plus 2 minus LCM is 6 here, and 9x plus 5x. This becomes 9x plus 5x, 14x divided by 4, square root becomes 2 into 1 plus x by 4 into half x by 8. So taking LCM, this becomes 12 minus 14x divided by 6 into 2 into 8 plus x. Sorry, should I write 8 plus x multiplied with 8 here. 2 cancels 8 by 4, and 6 by 2 becomes 3, 4 by 2 becomes 2. Okay, now this comes out as 12 minus 14x into 2 divided by 3. Now understand, 8 plus 6 can be written as 8 plus 6 divided by raised to power minus 1. This can be written as, first taking 8 common, so 8 raised to power minus 1, remaining 1 plus x raised to power 8 raised to power minus 1. 1 by 8 raised to power minus 1 is 1 by 8 into its expansion 1 plus nx, 1 minus x raised to power 8. So this will be 1 by 8 into 1 plus x by 8. So this is the complete expansion. We have brought the x in the numerator part. This is how we can solve it. Further, this can be solved and will be matched with the options if options are given. Here in the example, answer is just given like this only. Let's now move ahead to the next question. This question is kind of like an application of binomial. We have to find out the value of cube root of 1001 up to 5 decimal places. What we'll do simply, we'll break down 1001, its cube root. So 1000 plus 1. Or I should better write it. 1 plus 1000 as you have learned it. 1 plus x raised to power n. N is less than 1. Absurd value of n. So here now here we'll apply, first of all we'll take common. What? Because 1 plus x raised to power n will only work when x is less than 1. Na? Modulus of x is less than 1. So let's try to make x less than 1 by taking common. Let's take 1000 common. So 1000 can be written as 1000 common, and if we take 1000 common from here, its power will also be available in it, into 1 by 1000 plus 1 raised to power 1. 1000 is like, we know 10 cube root, 10's cube is 1000. So 10 cube root is 10 only. So it's 10 into 1 and 1 by 10 raised to 1 by 1000. So let's write it as 1 by 1000 only. Now here we can apply that particular line. Now 1 plus x raised to power n. Here it can be applicable because modulus of x is less than 1, and even the thousands x is 1 by 1000. If we take its square, it is negligible, almost negligible. So we can find out that its square will not be as much applicable to us. But let's try to find out its value first. So 10 is in multiple first. 1 plus n of x. N is 1 by 3. X is 1000. Let's take one more value. N into n minus 1. Okay. Divide by 2 factorial. That is 2 only. Into x squared. Into 1 by 1000 squared. And I don't think other terms will value, because they will give us very minute values, like very negligible. So we are neglecting the values in this. So let's find out now. Give me a moment. I'm saving the file. Okay. So 10, 1 plus 1 by 3000 plus 1 by 3 into 1 by 3 minus 1 becomes minus 2 by 3 divided by 1 by 2 into 1, like multiple 6 times 0 is 0 almost. So 2 cancels 2 here, and this becomes 10 into 1 plus 1 plus, first of all, 1 by 3 is 0.33. Okay, 0.0003, and then 3 almost. Then plus, sorry, minus. There is a minus sign here. Okay, this is actually 1 by 9 and then something something. So 1 by 9 is what? 1 by 9 is 0 0.1 and 1111. And how many times should we apply zeros before the point and the 1? 1, 2, 3, 6 times. So mm, 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 mm. So this will give us some value, big value. So even we are not able to subtract it. So we are also going to neglect it. So this becomes 10 into 1.000333. Let's now multiply. Let's just shift the decimal to its right place. This will become something this. This is our answer. This is one application of binomial theorem that we are seeing. Okay, so there are some other important series as well. Let's now discuss them. So first, exponential series. So E is an irrational number, as we are aware. And it lies between somewhere 2.7 to 2.8. Okay. Its value is correct up to 10 places of decimal. C is 2.71. I'm reading from my book, 28281, 8284. 2.71, 8281, 8284. Okay. And logarithm to the base E is known as the Naperian system. So named after the Napier, their inventor. They are also called as Napier logarithm. Whenever logarithm has the base to E, then they are called as uh, Naperian system, and also called as a natural logarithm. We are already aware about that. Let's talk about the series. So e raised by x is 1 plus x raised divided by 1 factorial plus x squared divided by 2 factorial plus x cubed divided by 3 factorial till infinity. This is e raised by x, where x can be any real or complex number, and e's value is defined by limit n tending towards infinity into 1 plus 1 by n raised by n, something complex. But this series is important for you to learn. Let's discuss about some more facts. E can also be written as 1 plus 1 by 1 factorial plus 1 plus 1 by 2 factorial plus 1 by 3 factorial up to infinity times. There is another important series, that is logarithm series, the last topic of this chapter. Actually, there's one more topic. Logarithm series, natural log of 1 plus x can be written as x minus x squared by 2 factorial plus x cubed plus, sorry, x minus of x raised to 4 divided by 4, here 3, right properly, 2, 3, 4 plus 5 minus, like this only, to infinity, where x is belonging from minus 1 to plus 1. Plus 1 is inclusive here. Or ln of 1 minus x minus of x minus x square by 2 minus x cube by 3 minus x4 by 4, going like this to infinity, where x is belonging from 1 minus of 1 to plus of 1. Plus 1 is not included. So important series. Sure. There's one more important topic left. So these are some observations from previous year questions directly, that the number of terms in x plus y plus z, the trinomial, should I say, expansion is n plus 2 c2. Coefficient of x raised to n minus 1 in x plus 1 into x plus 2. This series is n into n plus 1 divided by 2. Mostly there is a question with x plus 1, x plus 2 till x plus 99. You can see in the previous year question. X minus 99 still is given. N into n plus 1 divided by 2, same with a negative sign. Okay. One more important previous year concept is the number of terms. You have to find out the number of terms, in x plus y raised to power n plus x minus y raised to power n. So it will have n plus 1 divided by 2 terms and x plus y raised to power n minus x minus of y raised to power n will also have n plus 1 divided by 2 terms when and only when n is odd. If n is even, let me write this with a different. If n is even, then x plus y raised to power n plus x minus y raised to power n and x plus y raised to power n minus x minus y raised to power n. This is going to have n by 2 plus 1 terms, and this is going to have n by 2. Okay. And so this is the important concept. And always remember while solving questions, please take a keen note whether r plus 1th term is asked or the power of x is asked. So the scenarios change, right? Because the general formula is tricky here, and most of the time students do mistake in applying that formula only. Okay, so yeah, one more concept is there, and let me write it here only. If coefficient of rth, r plus 1th and r plus 2th term in 1 plus x raised to power n expansion R in AP, then the relationship between n square, n and r will follow this condition. If they are in GP, then the relationship will follow this condition. N minus 2r whole square is equals to 0. And everything else we have already covered. One more important thing, that m raised to power n plus m plus 1 raised to power n is less than m plus 2 raised to power n for all m n belonging to natural numbers. So this completes our binomial chapter. Thank you. Good night.